Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate the half angle expression, or evaluate the expression, which is using the half angle formulas when given an equation and a constraint. Now, remember previously what we've done is we've done these problems where we had, given a right triangle, or we actually were given an angle. Well, now we're given an equation where secant of alpha is equal to 3, where the constraint is the alpha has to be between pi halves and pi. So we got to kind of remember, well, all right, so where is this angle going to be? Because that's very, very important for creating our triangle. Because to do these problems, for sine, cosine, tangent, we need to, or to use the double angle formulas, we got to have the value of an angle. So let's go back and look at a triangle. Now remember our Cartesian coordinate system in the x and y axis. So remember, if we start an angle here, this would be 0. Here would be pi halves. Here would be pi. If I was like going around the circle here, this would be 3 pi over 2, and this would be 2 pi. Right? So what they're saying is our angle alpha has to be between pi halves and pi, meaning it's going to be in the second quadrant. All right. Now, what we're going to do is we're going to create a triangle based on that information. So remember, when we're creating a triangle based, with that information, our triangle has to be a central angle. So alpha is going to be right here. And then it also has to be perpendicular to the x-axis. OK? Now, the information we're given is secant of alpha is equal to 3. Now, remember, sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So remember, secant is the reciprocal of cosine. So therefore, if cosine is adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. The kind of issue is, though, we don't have a fraction. We don't have a ratio here. We just have a number. So the best thing to do is just to remind yourself that we can always rewrite 3 or any number as a fraction. So therefore, it's hypotenuse over adjacent side. So I'm going to write 3 over 1. Now, the other important thing to notice is since we're in the second quadrant, this distance 1 is in the negative direction. So this is actually going to be a negative 1. All right. Now, the next thing we need to do is we're still going to want to be able to evaluate for what the sine is. Anytime you have a right triangle and you have two sides, you might as well go ahead and use it. Now, you want to look for your Pythagorean triples or use the Pythagorean theorem. In this case, we do not notice this as a Pythagorean triple, so I'm going to use a Pythagorean theorem. I'll just use the height, which would be the opposite side of this triangle, as x. So I'll basically write x squared plus negative 1 squared equals 3 squared. Therefore, x squared equals 1. X squared plus 1 equals 9. Subtract 1, subtract 1. X squared equals 8. Take the square root, take the square root. X equals plus or minus the square root of 8. Now remember, we can always simplify the square root of 8. X equals plus or minus, break it up into square numbers, or the product of a square number times there. And therefore, x equals plus or minus 2 square root of 2. Also notice that this value, though, is positive, so we don't need to include the negative version of that. So we're just going to have 2 square root of 2. One thing I kind of skipped over, I just want to make sure we mention, remember that the hypotenuse is always directly across from the 90-degree angle. The side that's between, the leg that's between the angle and your right angle is always your adjacent, and this is always your opposite. Okay? Just wanted to make sure I went over that again one more time. All right, so now we need to evaluate for the sine of theta divided by 2. So that obviously is going to be the half angle, so we're going to want to use the half angle formula. So the main important thing here is to write down the half angle formula. Now for sine and cosine, we're going to use plus or minus. So it's 1 minus cosine of theta divided by 2. Now to determine if sine is going to be positive or negative, it's all dependent on where we're going to use alpha, not theta. Where alpha divided by 2 lies. Well, we know that alpha lies in the second quadrant, where sine would be positive. But we want to figure out where alpha divided by 2 lies. Well, when we do that, we get pi over 4 is less than or equal to alpha over 2, which is less than or equal to pi halves. Well, that's now going to be in the first quadrant, where, since that's still in the first quadrant, sine is going to be positive. OK, so to go ahead and do the rest of this problem, though, I'm going to have to erase this information. I'm going to leave the triangle because that's going to become important for us later. But I'm just going to erase the rest of this information here. OK, so now basically we need to figure out what is the cosine of alpha. Well, cosine of alpha, again, we wrote in the triangle for alpha, cosine is, again, adjacent over hypotenuse. So now, basically, I'm going to plug in that information. I don't need to write plus. I'm just going to write in 1 minus. Cosine is going to be negative 1 over 3 divided by 2. Now, basically, what we can do is add our numerator, add the fractions and numerators. So what I'm going to do is I'm going to rewrite 1 as 3 over 3 minus a negative is plus 1 over 3 divided by 2. I ran out of space. OK. Then I add my numerators together here. And when I do that, I get 3 plus 1 is 4 divided by 3 divided by 2. Now, to simplify this fraction, I'm going to rewrite 2 as 2 over 1. Then I'll multiply by my reciprocal on top and bottom. That's going to eliminate the 2 in the denominator. Well, not really eliminate it, but it multiplies to give me 1. So therefore, now I can just multiply across here. And what I get is 4 divided by 6. So now I continue my problem. So since I have the square root of 4 divided by 6, what I'm going to do is now take the square root of the numerator and take the square root of the denominator. So that's going to look like this, square root of 4 divided by square root of 6. I didn't simplify it for the pure fact that I know the 4 is a square number. So I can take the square root of that, and then that's over 6. Now, we don't really like to leave our answers with a square root in the denominator. So I'm going to rationalize my denominator. And then my final answer will be 2 square root of 6 divided by 6. Not really, though, because then 2 divided by 6 I can reduce to give me my final answer of square root of 6 divided by 3. OK, so now let's go and get into cosine. Now, cosine is going to be kind of the exact same thing, except now we're just using a different formula. So cosine is going to be, again, plus or minus. And we're going to have now 1 plus cosine of alpha divided by 2. OK, now, again, we need to determine is cosine positive or negative for alpha over 2. So again, you look at this. Again, pi forced alpha divided by 2 is between pi over 4 and pi halves, which is still in the first quadrant. So therefore, cosine is going to be positive as well. So I'll just leave that as the positive value. Then again, we know cosine of alpha, which is negative 1. I should write that in there. Is negative 1 over 3. So I do 1 plus negative 1 over 3 divided by 2. And basically, ladies and gentlemen, the operations is going to be the exact same thing again. You're just getting a lot of practice of combining fractions and so forth. So I write this as 3 over 3 minus, really plus and negative is the same thing as minus, minus 1/3 divided by 2. Combine my numerators. 3 minus 1 is going to be 2/3 divided by 2. Rewrite that as over 1, multiply by the reciprocal to simplify my fraction. And therefore, I get square root of 2 over 6. OK, now again, simplify, take the square root of the numerator and of the denominator. So I have the square root of 2 divided by the square root of 6. I can't really simplify that, so I can rationalize the denominator, though. So I'll multiply by the square root of 6 times the square root of 6. Now remember, you could actually divide these out into the square root of 1/3, or 1 over the square root of 3, which would have been perfectly fine. But if you do it this way, that's OK as well. Just remember, when you're multiplying square roots, you can multiply inside the radicands. So therefore, this becomes, I guess I probably should have simplified this. It's going to make it a lot easier. Anyways, we'll look at it. So it would be the square root of 12 divided by 6. The reason why it would have been easier, because now I have to simplify the square root of 12, which isn't bad. I mean, I did it. Where did I do that? Oh, that was a different problem. But you can simplify the square root of 6. You can break that up into the square root of 4 times 3 divided by 6. The square root of 4 is 2 times square root of 3 over 6. That now reduces to the square root of 3 over 3. What I was trying to say was, I'll just do this over here. The square root of 2 divided by the square root of 6, you can divide, just like how I multiplied those inside radicands, you can divide those, which would have given you 1 over the square root of 3. which then, if you rationalize the denominator, you would get the exact same answer, square root of 3 over 3. Just another way to do it. All right, let's get into now tangents. So tangent, you see here, there's two different formulas for, or three different formulas for tangent. I want to avoid the one with the square root for sure. And I also want to avoid the one where we have a denominator or our denominator is a binomial. I'm going to focus on the formula for tangent, which is 1 minus cosine of alpha divided by sine of alpha. So now we need to know not only what cosine is, but what sine is. And remember, sine is opposite over hypotenuse. So it was very helpful that we went back and found 2 square root of 2. So therefore, I do 1 minus, again, cosine is negative 1 over 3, divided by sine, which is 2 square root of 2 over 3. It's going to be fun stuff. Again, we combine our numerators. You should be familiar with this. 3 over 3 plus 1 over 3 divided by 2 square root of 2 divided by 3. Those combine to 4 over 3 divided by 2 square root of 2 over 3. Now, unlike having to rewrite that as a fraction and then multiply by reciprocal, I already see that this is a fraction. So I can just multiply by the reciprocal of that, which would be 3 over 2 square root of 2. And what's helpful about this now is now the 3's divide out. Any fraction multiplied by its reciprocal multiplies to 1. The 2's, 4 divided by 2 is just 2. So therefore, I'm left with 2 over the square root of 2, which, again, I can rationalize the denominator. And that leaves me with 2 square root of 2 over 2. Now the 2's divide out, leave me with the final answer of square root of 2. So there you go, ladies and gentlemen. That is how you evaluate for the half angle for sine, cosine, and tangent when given an equation and constraint. Thanks.